You think you're anonymous. You clear your cookies, use incognito mode, maybe even a VPN. But what if I told you that right now, as you watch this, your browser is leaving behind a digital fingerprint, as unique as the ones on your hands, that follows you everywhere you go online? In 2010, the Electronic Frontier Foundation made a discovery that would change everything we thought we knew about online privacy. They ran an experiment called Panopticlick, analyzing anonymized data from around 500,000 distinct browsers. The results were shocking. 84% of all browsers had completely unique configurations. Among browsers with Flash or Java installed, 94% were unique. The average browser contains at least 18.1 bits of entropy, meaning only 1 in 286,777 other browsers will share its fingerprint, unlike cookies that live on your device and can be deleted. Browser fingerprints are characteristics your browser reveals automatically every time it connects to a website. These fingerprints persist across incognito mode, VPN use, and cookie clearing sessions. But here's where it gets truly disturbing. This isn't just theory. In 2025, researchers finally proved what privacy advocates feared most. Imagine if every time you signed your name, microscopic variations in your handwriting were recorded and analyzed. That's essentially what's happening with your graphics card right now. It's called canvas fingerprinting, and it uses the HTML5 canvas element, basically a painting box in your browser. When you visit a page, the fingerprinting script draws text with a chosen font and size, adds background colors, then calls the Canvas API's toDataURL method to get the pixel data. Finally, it takes the hash of that text-encoded pixel data, which serves as your fingerprint. Your graphics processing unit and graphics driver installation cause the fingerprint variation. Every device renders images slightly differently due to hardware variations. Color distortions, shape variations, all invisible to the human eye. This technique was first described in May 2012 by researchers at UC San Diego. The Tor project put it bluntly. After plugins and plugin-provided information, we believe the HTML5 canvas is the single largest fingerprinting threat browsers face today. Canvas was bad enough. But then researchers discovered they could go even deeper, literally into your hardware. If Canvas fingerprinting reads your GPU's handwriting, WebGL fingerprinting reads its DNA. WebGL, or Web Graphics Library, renders 3D graphics and accesses lower-level hardware information. The outcome relies heavily on GPU configuration. Variation in GPU model, driver types and versions, number of GPUs, GPU memory size and compute capabilities, even the GPU to motherboard connection pattern. Every GPU produces microscopic variations in floating point calculations, shader compilation, and pixel rendering. Think of it like handwriting analysis. Two people writing the same sentence produce subtly different results based on muscle memory. Your GPU's handwriting is similarly unique, and it cannot be easily spoofed. Random changes create detectable inconsistencies. If your browser claims to have an RTX 4090, but renders like integrated graphics, anti-bot systems flag the mismatch instantly. These systems work by rendering hidden test scenes and comparing results against known GPU signatures. But fingerprinting doesn't stop with what you see. It also listens to what you can't hear. The next technique sounds like science fiction. Websites identifying you by how your computer processes sound, sound you never hear, sound that never touches your speakers. Here's how it works. A script creates a hidden audio context using the Web Audio API. An oscillator generates samples mathematically, producing a periodic waveform with a specified frequency, typically a 440 Hz sine wave. That's a standard A4 note. The signal passes through a dynamics compressor node, which lowers the volume of the loudest parts, and has properties like threshold and knee that create more variability between browsers. The resulting audio values are hashed into a unique identifier. Why does each device produce different results? All major browser engines base their Web Audio API implementations on code, originally developed by Google in 2011 to 2012 for WebKit. But since then, browser developers have made many small changes. Chrome uses a separate fast Fourier transform implementation on macOS, producing different oscillator signals and different vector operation implementations on different CPU architectures. Floating point arithmetic introduces calculation discrepancies. Even the Android version matters. different results on Android 9 versus 10 on the same device. Starting in Safari 17, Apple added a privacy feature that injects random noise into audio signals generated via the Web Audio API when in private browsing mode. 3 invisible tracking methods, all working simultaneously. But here's what they're not telling you about who else is using this technology. While you were worrying about targeted ads, intelligence agencies discovered the perfect tool for mass surveillance. No warrants needed, no consent required. The NSA used a system called X-Keyscore to hoover up internet traffic and extract browser fingerprints to assess the exploitability of targets for cyber operations. The UK tax agency, HMRC, explored fingerprinting solutions for tax fraud detection. This technology creates persistent profiles without consent or warrants. The connection between real-time bidding and personal data leaks is well established. Data often ends up with data brokers, enabling financial fraud and surveillance. And here's why it's perfect for surveillance purposes. It works passively, no software installation required. It can't be turned off like location services. It tracks across VPNs, across Tor if not configured properly, across different networks. It links anonymous accounts to real identities. It correlates activity across years of browsing history. It cross-references with other databases for complete profiles. There's a dual nature to this technology. The same tech is used by banks. A 2024 Cyber Edge survey showed 68% of financial firms reported lower unauthorized access after integrating device fingerprinting into their fraud detection stack. It identifies characteristics of botnets, flags impersonators. Security versus surveillance. Identical technology, opposite intentions. So government agencies are watching. But the advertising industry took this even further. Every click, every page, every search sold to the highest bidder. And your fingerprint is the key that unlocks it all. The global programmatic advertising market hit $595 billion in 2024. In 2013, less than 1% of the top 10,000 websites used browser fingerprinting. By 2021, a quarter of major sites deployed it. A study of the Alexa top 100,000 websites found nearly 10% used scripts to generate fingerprints, often without informing users. In February 2025, Google reversed its anti-fingerprinting stance, allowing it for advertising purposes. The UK Information Commissioner's Office called the move irresponsible. Researchers at Texas A&M University in 2025 found websites covertly using browser fingerprinting to track people across browser sessions and sites. They developed FP-Trace, a measurement framework that detects fingerprinting-based tracking by analyzing how ad systems respond to fingerprint changes, by correlating browser fingerprints with ad behaviors. They established the direct relationship between web tracking and fingerprinting. When your fingerprint changes, advertiser bidding changes. Your unique fingerprint determines what ads you see, what prices you're shown. Target shows different pricing based on location. Prices are cheaper if you're checking from across town versus from their parking lot. Now you understand the scope, but can you actually protect yourself? That's where the paradox begins. Here's the cruel irony. The more you try to hide, the more you stand out. The more privacy-centered add-ons you install in your browser to protect privacy, the easier it becomes to identify you because of the unique of your browser's configuration. Installing Canvas Defender, WebGL blockers, or font randomizers creates a profile that stands out. 99.24% of users can be uniquely identified when combining browser and device fingerprints. Websites can detect when you're using anti-fingerprinting tools. Random spoofing creates detectable inconsistencies. It's like a cat wearing a dog mask, obvious to anyone paying attention. If your browser claims to have an RTX 4090, but renders like integrated graphics, that's an instant red flag. So what actually works? The hard truth is this: perfect privacy requires breaking the modern web. Perfect functionality requires surrendering your privacy. You cannot have both. Tor browser is the gold standard. It's engineered to make all users look identical by standardizing observable values. It uses a technique called letterboxing that adds margins to browser windows so users fall into standard screen size buckets. It standardizes user agent values. All windows appear as Windows 10, all macOS as OS X 10.15. It blocks Canvas fingerprinting by default. All Tor browser users send the same value back. The trade-off? Significantly slower browsing speeds, Many websites block Tor traffic, and some functionality breaks. For daily browsing, Brave or Firefox with enhanced tracking protection offer a balanced approach. Brave uses something called farbling, adding subtle, random noise to fingerprinting APIs without breaking functionality. Firefox blocks known fingerprinting companies, but has a limitation. It only blocks known companies. New techniques can slip through. Here's what doesn't work. VPNs alone only hide your IP address. They do nothing to alter the other 49 plus fingerprinting parameters. Browser extensions that spoof your user agent create massive inconsistencies that are easily detected. Incognito mode does absolutely nothing against fingerprinting. So test yourself. Visit the EFF's Cover Your Tracks website right now. See exactly how unique your fingerprint is. The number might shock you. Your browser is a window to the web. But it's also a mirror, reflecting details about you that you never knew you were sharing. In the digital age, privacy isn't just about what you choose to reveal. It's about what you can't help but reveal. And that's the real fingerprint.